All right, so the last topic that will show up on our third exam is about functional groups. And functional groups are essentially the body parts of organic compounds. So let me define it. They are groups of atoms with a specific connectivity. And like I said, I call these the body parts of a molecule. So just like with a human being, you've got hands, feet, arms, legs, things like that. We use the same terminology with organic compounds to describe the different pieces coming off of them. We've already seen a few of these functional groups. So we saw alkanes. Whoops. Got the L. And we saw alkenes. And we saw alkynes. And what was an alkane again? Does anybody want to help me? Only single bonds, exactly. So it's a carbon-carbon single bond versus an alkene, which is what? Double bond. Those are easy. And then alkyne must be a triple bond. So we've already seen three different functional groups. So for example, in this first molecule, we could go ahead and we could try to circle or highlight the various functional groups in here. So for example, this top one, I could say this functional group must be an alkyne, right? We want to be as specific as possible. So instead of just saying hydrocarbon, we could say specifically this portion of the molecule is an alkyne. All right, and then there's this one, which would be an alkene. And would this be a cis or a trans alkene? Trans, exactly. So this would be a trans alkene. We only need to specify cis or trans with alkenes, not with alkanes or alkynes, because they don't have any sort of dimensionality to them. All right, and then last but not least, we could pick any one of the remaining single bonds. So for example, I could pick one of these and I could say this is an alkane. It only has CC single bonds. Does that make sense? So those are the easy ones, the ones only containing carbon and hydrogen. However, like I said yesterday, your body is made up of a lot of oxygen and nitrogen too. So we've got functional groups with oxygen and nitrogen. We'll start off with the oxygen ones. All right, and whenever I draw these, essentially I'm going to use an R group as a placeholder. So basically it's just like an empty filler thing. And we're going to start off naming all the different functional groups that contain oxygen. So first one we'll do is alcohols. And with alcohols, the general formula can be written as the following. I'm going to use that space holder. So it's going to be ROH. So that oxygen has two lone pairs off of it. So alcohols in this case can do what sort of intermolecular force? What's their main intermolecular force? Hydrogen bonding. So alcohols can hydrogen bond. They're pretty common. So let's take a look at some examples. Let's say I've got a 2-carbon alcohol. Looks like this. I'm going to fill in all of the hydrogens. If we think about it, it's a 2-carbon alcohol. So what sort of prefix should we use? Do we use meth? Eth, exactly. So eth is going to be our prefix to indicate that it's a 2-carbon alcohol. And then to indicate that we've got an alcohol, we use an OL suffix. So for example, the name of this molecule would be ethanol, indicating that it's a 2-carbon alcohol. I'm not going to be quizzing you on the naming of these, but I do want you to know that a suffix ending in OL is for alcohols. That's pretty important to remember. Yep.
Why would it not be ethyl?
That's a good question. So quite often you pick the ones so that it flows the best off your tongue. Ethyl just sounds kind of funny. Ethanol makes a lot more sense. There is some wiggle room with that. The other thing too is by having the AN in there, so ethan, indicates that the carbon-carbon bonds are all single bonds too. So it's a combination of an alkane and an alcohol. Exactly. All right, so alcohols are pretty common. Ethanol is most commonly known as drinking alcohol, right? So if you drink vodka, beer, wine, anything like that, it has ethanol in it. Do you want to drink any other types of alcohol? No, very much no. In fact, a lot of other alcohols will make you go blind if you drink them, so you have to be very, very careful with what type of alcohol you drink. All right, the next one is ether. And ethers are a little bit different than alcohols. An ether still has an R group as a placeholder, and it's still bonded to an oxygen, but instead of having an OH, it has another R group coming off the other side. So it's got 2 carbons attached to an oxygen in the middle. Let's make a note that there's no OH group. All right, so we'll take a look at another one of these. And let me make sure I'm doing it the same. So the first one we'll look at is diethyl ether. This is commonly used to clean auto parts and things like that. It's very stinky stuff. Oops, sorry, this should be a C. And then we'll try to explain why the name is the way it is. But first, let's draw in all of the hydrogens. And that interior oxygen has 2 lone pairs. So if we look at it, first thing I'm noticing is we've got di as our prefix. That means 2, right? And then we've got diethyl, so 2 2-carbon chains. And then ether means that there must be an oxygen in between. So for example, if we look down here, we've got an oxygen in between 2 2-carbon chains. So over here we've got an ethyl group. And over here we've got an ethyl group. So this would just simply be referred to as diethyl ether. Make sense? So that R group is always going to be some sort of carbon placeholder. In this case, it could be an ethyl group, it could be a methyl group, it could be any sort of carbon-containing group. Does that make sense? All right, so now let's take a look at another one, and I want you to help me identify all of the various functional groups in here and then double check with your neighbor. So let's try to do this as a class. So for example, let's say I'm looking at this functional group. What is this? Alkane, not too bad. All right, what about this one? Transalkene. Yeah, exactly. So you notice how transalkenes tend to be zigzaggy, where cisalkenes have that C shape to them. This is more zigzaggy than a C shape, so we know it's trans. And then down here, what is this? Alkyne. And what about this? Alcohol. So it depends. We're not going to get into the nitty-gritty group but it can be called an hydroxy group, but most people call it an alcohol. Yeah. Yep. And then over here, we've got one more functional group. It's an oxygen in between two carbons. So what would that be? Ether.
Oh, I was going to ask. Like, so it doesn't matter how many. That I had the other
Yeah, as long as you've got a carbon on each side of the oxygen, we would consider it an ether. And an alcohol in this case is different from an ether because it only has one attached carbon, not two. So they are different from one another. Primarily, alcohols can H-bond, ethers cannot, right? So they're going to behave very, very differently as functional groups.
Since this is confusing, this is worth a lot of points.
No, ideally, I want it to be kind of freebie points. Just as long as you know the names, you should be able to get full points on this, right?
Wait, so could you elaborate more on the alcohol thing?
Yeah, so an alcohol is always OH attached to a carbon, right? Versus an ether, you've got an oxygen in between two carbons. So an ether has no hydrogen coming off the oxygen. It can't hydrogen bond. So it behaves very differently from an alcohol, which can hydrogen bond. All right, let's do a few more. We're going to throw a curveball in now because I figured it was getting too easy. These are called carbonyl functional groups. It's not too bad. I think the practice exam is pretty close to what I would give you. So, like I said, if you can do the practice exam, you'll be fine. All right, carbonyl functional groups have some sort of general formula that looks like this. Where you've got a CO double bond in it. So anytime you see a CO double bond, you've got a carbonyl functional group. However, there's a whole bunch of different types. So let's look at the different types. Okay, so the first one, so let's say we've got a placeholder here. And then you've got a carbon on both sides. So for example, because you've got a carbonyl in between two carbon groups, this would be referred to as a ketone. So carbon on both sides. Does that make sense? So that's one functional group. Let's do the next one. Yeah, it's basically saying it's some sort of hydrocarbon coming off that right-hand side. It could be a methyl group, it could be an ethyl group, it could be any carbon-containing group, essentially. And also, if you remember with bond line structure, that this central carbon is an assumed C, right? So I drew in that green one just in case you forget. But anytime we don't have that shown, that's assumed to be a carbon. For our next functional group, we've got a hydrogen coming off of one side, and this is called an aldehyde. So carbon on one side, hydrogen on the other. So that R group on one side is an assumed carbon, the hydrogen's off the opposite side, so we'd call this an aldehyde. Next one, still has a carbonyl group, but now it has an OH group. This is called a carboxylic acid. Oops. This has a carbon on one side. Oop. And OH on the other. Some people will look at carboxylic acids and they'll say, well, isn't that an alcohol? Kind of, but more specifically, we want to describe it as a carboxylic acid. This is by definition, more acidic than a normal alcohol. So we always want to use the most descriptive terminology available to us when describing functional groups. So don't call this an alcohol, call it a carboxylic acid. And we've got a couple more. Oops, let me slide this down. All right, for our next one, we've got a nitrogen on one side and a carbon on the other. This is called an amide. And that R group for the nitrogen can be any sort of hydrogen or carbon. It just is a placeholder for either in this case. And then last but not least, we've got one, whoops. It looks like this. This is called an ester, not an ether. It gets confusing. But this has a carbon on one side exactly. It can be anything, but in this case, it's different from a carboxylic acid. So let's zoom out and look at this. You see how an ester has an OR versus a carboxylic acid that's an OH? In this case, the ester's R means an implied carbon, right? So it's an O carbon group coming off one side and a carbon coming off the other. Does that make sense? So these are the 5 main carbonyl functional groups. I want you to know these are the most common ones in biology. In particular, that's why we need to know them. All right, so we've got another problem on your sheet. So again, I want you to identify all of the different functional groups in the compound shown. I think it's the 3rd one on the page. 3rd and 4th, actually.
Do the alkenes as well as these?
Yeah, do as many as you can. More practice is always better. So let's walk through the first one, and hopefully that will make the second one a little easier. So for example, like I said, always identify your carbonyl group. So the first one I'm identifying, I've got a carbonyl group right here. I'm going to highlight that in yellow. Can everybody see the yellow? Okay, so that's one carbonyl group. It looks like we've got a carbon on one side of the CO double bond and a hydrogen on the other side. What is this going to be called then? Aldehyde. So it is a carbonyl, but more specifically, it's an aldehyde. It's got a hydrogen coming off one side and a carbon coming off the other. Yep.
You don't do the hydrogen on the left, like on the test. What do you get that wrong? Because I have that as an aldehyde.
As long as your label is correct, that's fine with me. Yep.
So when I was doing that one, I was in between aldehyde and ketone. What's the difference between the two? Like, why is it not a ketone?
Yeah, that's a good question. Actually, that's what our next one is. So let's highlight it and compare. So our next carbonyl group, if we look at it, we've got a CO double bond with 2 carbons coming off each side. In this case, this would be a ketone. So a ketone has a carbon coming off each side. An aldehyde has 1 carbon, 1 hydrogen. Okay, so that's another functional group. Let's go identify the remaining pieces now. I don't see any other CO double bonds. So for example, my remaining pieces, I could say there's a piece right here, an oxygen in between 2 carbons. So what would this be called? Ether. And then over here, I've got an oxygen, specifically an OH coming off a carbon. So what would this be called? Alcohol. All right, and then right here, I've got a double bond, transalkene. Over here, I've got a triple bond, alkyne. And then I can pick one of these remaining single bonds. This is kind of the freebie point. What is this? Alkane.
So if you're not circling that R, you should be on the test. How much do you like your score on the right one?
blackmail, I see. All right.
No, bribery. Bribery.
So let's go ahead and do this one as a class. So first thing I always do is highlight my functional groups containing carbonyls. So for example, I see a carbonyl right here. So I've got a carbonyl with a nitrogen off one side and a carbon off the other. What is this called? Amide. Or amide if you're British. And then the next one we've got right here. It's got a carbonyl with a carbon off one side and an oxygen off the other side, but not an OH. It's an OR type group. Yeah, it would be an ester. All right, we've got one more down here. I'll highlight this one in yellow. This one's got a carbon on one side and an OH off the other, so what would this be called? Carboxylic acid.
Is there not a ketone next to that? The HCOH3C?
Are you talking about this piece down here?
Yeah.
Yeah, so this is another functional group. If we look at this functional group, we've got an oxygen in between two carbon atoms. What do we call that? Ether. All right, some people get confused too, and they say, well, what about this one? That looks like a carbon or an oxygen in between two carbons. Technically, that's bound to a carbonyl group, so we've already described it as an ester. We don't need to describe it again as an ether. In fact, that's confusing for people. So don't label that one. We've already identified that. What's this one called again? Alcohol. What's this one? Alkyne with the Y-N-E. What about this one with the double bond there? Transalkene. And just for good measure, let's identify this one. Alkane. All right, so these are pretty much all of the various functional groups we could identify in this compound. For the problem of the day, it's just a practice one, so you can go through and identify that. That's just a good example of what might show up on the exam, and ideally just freebie points for you on Monday. What I did do was I made a Quizlet for all the various functional groups, because I know some people like doing the Quizlet thing on their phone over and over again, so you're welcome to use that as well. I'll post that on the class website. There's a supplemental video here as well that kind of walks you through a crash course. There's one other functional group, and it's so common, I just wanted to show it to you. And these are aromatic or benzene functional groups. Yes, this one could be on the test too. And we actually saw this with our Tylenol and aspirin, where we had this ring of carbon atoms with alternating double single bonds around it. So anytime you see this six-membered ring of carbons with alternating double or single bonds, you can call this a benzene. If it's attached to something else, you can just call it aromatic. And like I said, oftentimes what people do, because it's a lot of carbons and hydrogens to draw, is they just omit them and draw them in bond line notation like this. You can show them either way, but they're so common in biology, I did want to show you that this is a benzene molecule. If it's attached to something else, so for example, if we've got an R group coming off one side, we would call this aromatic. So for example, you could circle this and say this is an aromatic functional group coming off. Make sense? All right, I was planning on going into polymers, but I think instead of doing that, we're going to just do a few more practice problems with our last 5 minutes. So let's go ahead and look at some practice problems. Which of the following organic compounds will most likely be a liquid at room temperature? Oh, they forgot the B here. Well, let's actually practice this. So methane, how many carbons will it have? 1. All right, what about ethane? 2. What about propane? 3. Butane? 4. They did this in order. Pentane would be 5. All right, so let's just think about methane for a minute. Methane is pretty small. Is that likely going to be a gas or liquid or solid? Gas. So for example, we know this is going to be a gas. Which one do you think is most likely going to be a liquid? Probably pentane, although butane can also be a liquid under the right circumstances. So at room temperature, the more carbons you have, the more likely it is going to be liquid. Why is that? It's heavier, it has more dispersion forces, right? So when we talked about dispersion forces, we said it depends on the surface area. Pentane has 5 carbons, therefore it has a much bigger surface area than methane. All right, let's do another one. The following chemical belongs to what family of organic compounds? Alkene, it's a double bond, right? What's the shape? In this case, we can't identify cis or trans because we've got 4 hydrogens. Yeah, this would be trigonal planar. So make sure you do remember the relative shapes of all of these because that could show up on the final. What is an alkane again? Yeah, so the first one? Single bonds. What about alkynes? Triple bonds. Aromatic? It's the ring. And then an aldehyde, we said, is a special carbonyl. And what's coming off each side? An aldehyde has 1 carbon attached, 1 hydrogen attached. So this would be an example of an aldehyde. So it's definitely not an alkene here. All right, let's do a few more. So the red balls equal oxygen, black balls equal carbon, and white equal hydrogen. So which functional group does the following chemical contain? For all of them. And then we'll be specific later. So they all look different from each other, but when I'm looking at this, they all have this commonality. What do we call anything containing a CO double bond? Not quite. That'd be a OH coming off. Carbonyl. So these are all carbonyls, but what I kind of describe carbonyls as is, like in biology, you'll say, oh, mammals, right? Mammals are a huge subclass of a bunch of different animal types. We want to be specific with their names. So let's try to be more specific. What would this be called if it's got a hydrogen coming off the carbonyl? Aldehyde. What about this one where you've got a hydrogen and a carbon coming off of it? So this one's an aldehyde because it has a hydrogen. This one's also an aldehyde. So aldehydes can have 2 hydrogens. They're just not super common. That's formaldehyde. What about carbonyl where you've got a carbon coming off both sides? Ketone. People will also ask me, do I grade on spelling? Depends. If I can get the general idea of what you're trying to convey, I'm not going to be nitpicky. But if you're just writing gibberish, obviously I won't give you credit for that. So yes and no. Okay. Let's do the next one. Which of the following compounds would you expect to be responsible for the fragrance of pears? And then I give you a hint saying esters smell good. All right, let's look at the first one and do process of elimination. This has an OL suffix. So what's that going to be? Alcohol. This one has a ketone suffix, so what will this be? It'll be a ketone. So it has a carbonyl group. And this one, if we look at the suffix, has aldehyde in there, so it's got to be an aldehyde. This one has an ether suffix, so that means it has to be an ether, which means process of elimination, this one is likely going to be our Ester, right? I'm not going to be super picky about naming of these. You won't cover that until you take more chemistry. All right, one more, and then we'll call it quits. Many natural and synthetic fibers such as silk, wool, and nylon all have this functional group in common. What is this called? It's an amide, exactly. It's got a nitrogen coming off one side of that carbonyl, so this would be an amide. So make sure you do review a lot of these nomenclature problems and make sure you can identify functional groups.